Hello everyone, welcome to the second part in the series of lectures on scale development. In part 1, I talked about an introduction to scale development, hypothetical construct, the importance of developing scales, and for today, I'll be discussing the characteristics of a good scale. Okay, before we continue, I'm inviting everyone to please subscribe to my channel. 90% of the people who are watching my lectures and tutorials are not subscribed, so I really would appreciate it if you can help me and help my channel by subscribing. Thank you very much. So for today, we'll talk about what are the characteristics of a good scale. And generally, there are two categories that I will discuss. The first one is the simpler one, which are the design properties. I'll just breeze through these things, but the more important characteristics of a good scale would have to pertain to their psychometric properties. And I'm talking about, of course, validity and reliability. So when we say design properties, there are a number of things that you should look into. The first one is that as the developer of a scale, you have to be very clear with regard to your purpose. Why are you creating a scale? What domain are you measuring? What construct are you measuring? You have to be very sure about that. Who is your target audience? Did you design this particular scale with the intention of administering it to elementary school students or to college students? Our knowledge of who our audience will inform some of the more important decisions that we will do in the development of our scale. Second, the content has to be specific and standardized, meaning to say that you cannot simply include anything that you want in your scale. You have to have some kind of standards, some kind of planning to begin with. Now, what kind of items do we include? There is a specific kind of phrasing that is necessary, and that has to be uniform across the items. When we administer this, it's important that there is uniformity also in the procedures. So things like that have to be considered. The next one is something that I also mentioned a while ago, is having standardized administration procedure. So if this is given as a pen and paper test, are there specific restrictions with regard to time? Although I don't see how that will be necessary, not unless you are developing a scale that measures some kind of ability. But that's not our intention here. There should also be a uniform set of instructions in terms of what to do. Does the respondent have to think of a specific time frame in answering the particular items? Should their mindset be in reference to the last 2 weeks or the last month? So that will be very important. You have to think about how you will effectively administer this and what your exact instructions will be, because they would have an impact on the way the participants respond to your scale. And finally, there should be a set of scoring rules. There are a couple of scoring rules that you can consider. It's either you can sum the items to generate a composite score. Some items might be negatively phrased, and so there needs to be an instruction that tells the one who will score the test to reverse these items before you compute for the total score or before you sum the score. Another option would also be to compute for the average score. So regardless what your scoring rules are, it's important that that is established and that those are communicated to the ones who will be using the scale. All right, so let's now go to the more important set of characteristics for a good scale, and those would pertain to reliability and validity. To some extent, these terms are not very new to us. I'm sure that you've heard of the term reliability and validity before. Of course, when we say reliability, this refers to the characteristic of a scale that allows it to consistently measure whatever it is measuring. So that means to say that let's say, for example, if I take the test twice, time point 1 and time point 2, a consistent and reliable scale would generate roughly the same score at time point 1 versus at time point 2, especially if the construct that you are measuring is meant to be stable. Although this is not always the case, there are some constructs that are very temporary, such as mood, constructs that are more of a state rather than a trait. So those we don't expect to be as stable across time. No, but for constructs that should be stable, then the instrument must be able to reliably capture that. Of course, aside from that kind of reliability, for scales that measure constructs that are more state-like, they're more fluctuating, there are also other forms of reliability that have to be measured, including internal consistency, things we will talk about in a little while. Another characteristic of a good scale, of course, is validity. So when we say validity, we know it as the characteristic of a scale which measures what it intends to measure. So if the author said that the scale is meant to measure self-efficacy, the fact that it actually measures self-efficacy speaks to the validity of the scale. But how do we know that? How do we establish the fact that it's actually measuring self-efficacy? So those are the things that we will talk about for this particular lecture. So let's first define what reliability is. And you will notice from the definition that it's quite different from our common knowledge of what reliability is. So reliability is defined as the estimate of the proportion of variability in examinees' obtained scores that is due to the true differences among the examinees on the attributed measures of a test. So that definition is quite different from how we commonly understand reliability. So let's try to understand what this definition means. But in order to do so, we have to consider what a score really contains. So imagine yourself that you are taking a test. You're answering one of these scales. You are reading the STEM statements, you are reading your options, the response set, and then you make the decision to select a particular response among the option of response. And let's say, for example, that for most of the items, you strongly agreed in many of the items. And therefore, because strongly agree have a higher numerical rating, that means to say that your score will typically be higher. For the sake of an example, let's say that your score is 25. So X represents score, X is 25. Now, according to the classical test theory, any score, such as 25, actually has two components. And those components are referred to here in the equation as T and E. T refers to the true score component. So if you remember in part 1, when we were talking about hypothetical constructs, we suggested that the things that we are measuring are things that are within the individual. And supposedly, let's say, for example, intelligence or self-efficacy, each individual has a true level of intelligence, a true level of self-efficacy for a specific domain. And that true level of self-efficacy, of intelligence, of whatever hypothetical construct is what we refer to as the true score. So anytime that you see a score such as 25, it is to our understanding that that is meant to estimate the true score. And so we would think that an important component of that 25 would have to be the true score, although we don't really know what the true score is. Now, the other component of that 25, of that score, is what we refer to as an error component, which tells us that 25 is partly a reflection of the true score, but also part of it would be an error component. And what would these error components be? What are other things that can influence the score of 25 aside from the true score of the construct? So we can think of a number of randomly fluctuating variables as a source of error in our measurement. For example, if I took the test and I'm a bit hungry, and because I'm hungry, I'm slightly rushing in selecting my responses, and therefore that might kind of slightly contaminate the truthfulness for which I am answering the response. And that introduces some kind of error component. Or for example, I misread some of the things that are in the items. That also introduces some kind of error component. So in summary, the true score component reflects the examinee's status with regard to the attribute that is actually measured. While the error component represents measurement error or component of the score that is determined by irrelevant factors that have unpredictable effects on the examinee's test score. Right? So the question is, in our hypothetical example, we used a score of 25. How much of 25 reflects the true score and how much reflects error? And that is a question of reliability. Now let us go back to the definition of reliability once again. So reliability is an estimate of the proportion of variability in the examinee's obtained score that is due to the true differences among the examinees on the attribute that is being measured by the test. And for that, let's try to illustrate that particular definition. So imagine that there is a group of individuals represented by this circle. And let's say, for example, that the construct that we are talking about is academic self-efficacy. For a group of students, we anticipate that they would have different levels of self-efficacy. Some students would have higher self-efficacy. Some students would have lower self-efficacy. What is self-efficacy again? The belief that you can be successful in a given academic task, given that this is academic self-efficacy. So some students would have higher belief in themselves, some students would have lower belief in themselves, and then some would have kind of average level of belief in themselves, average self-efficacy. So the bottom line is that we expect that there would be variability in the true score or the true level of self-efficacy in a group of students. And that would be this one, true differences among examinees on the attribute measured by the test. Now, let's imagine that this group of participants who to begin with have variability in their true level of self-efficacy. Let's imagine that they take an academic self-efficacy test. And so as we would imagine, as they're answering this, some would score high on self-efficacy and some would score low on self-efficacy. And the rest would score average on that particular scale. So there will be variability, but this time it's variability not in the true difference, but variability in the examinees' obtained scores. Now the question is, how much of the variation in the test scores reflect the variation in the true score? So as you can imagine, reliability can be illustrated by some kind of overlap between these two types of variation. So how much of the variation in the test scores represent the actual variability in the true score? So if it represents all of the variability in the true score, then this would be a very reliable instrument. But if the proportion of the variability in the test scores is only a small portion or represents only a small portion of the actual variability in the true score, then this would mean to say that this is an unreliable instrument. So again, the bigger the proportion, the more reliable. The smaller the proportion of the variability in the test scores is similar to the is due to the true differences in the true scores, the lower the reliability of the test. Okay? So that is kind of the technical definition of what reliability is. And that proportion is represented by a numerical value which we refer to as the reliability coefficient. So what is it? It is a value that is computed to determine how reliable an instrument is. It indicates the proportion of the variability in the obtained test scores that reflects true score variability. So let me draw those circles back. So if these are your variability in test scores and this is your variability in the true score, how much of the proportion in the variability of the true score reflects the variability in the true score? For example, if the reliability is 0.84, that means to say that 84% of the variability in the score is due to the true score differences among the examinees. So let's say, for example, that's this, it's represented by this overlap, then this would be your 84%. And the one that is outside the variability that is caused by error, this one, this would be your remaining 16% variability right here. Okay, so that is your reliability coefficient. And reliability coefficients, we should be familiar with them because they simply are, more often than not, correlation coefficients. However, one thing that we have to remember is that the reliability coefficient does not provide information about what is being measured. It only indicates whether the attribute being measured by the test that is being assessed is consistent and precise way. But you can consistently and precisely measure the wrong thing. So basically what we're saying is that reliability does not equal validity. So let's say, for example, that we have a target here. So here's a bullseye mark. So let's say, for example, you're a shooter and you're a consistent shooter and most of your shots fall here. So you're consistent, you're reliable. However, you're not hitting what you're supposed to hit. So this kind of illustrates an instrument that might be reliable, but because it's not measuring what it intends to measure, it's not a valid instrument. So as much as this is important, it's important that you become consistent in targeting, in measuring what you actually want to measure. And this is what it means to be reliable and at the same time reliably measure the correct thing. So there is reliability and validity. So what are different ways of establishing reliability? Now I have a couple of techniques here, although mind you, not all of them might be applicable for the purpose of scale development, as in developing scales specifically for research. Some of these are probably more applicable for developing instruments for commercial use. But anyway, let's discuss some of them and then I'll just point out which one is very important for scale development for the purpose of research. So the first one is called test-retest reliability. So how is this done? So you administer the same test on the same group on 2 occasions. So let's say, for example, so you have time point 1 and then time point 2. So the idea is that there are a group of individuals. So participant 1, 3, 4, 5. So let's say, for example, there are more participants. And then let's say, for example, for time 1 during the first test taking, participant 1 got 23, participant 2 got 12, participant 3 got 20, participant 4 got 15, participant 5 got 24. At time point 2, if the instrument is reliable, our expectation is that the instrument will be able to measure relatively the same score, especially if the construct is something that is meant to be stable. So if the instrument is really measuring a stable thing, therefore the scores should not be very different. So hypothetically, it might not be exact, but let's say, for example, participant 2, time point 2 got 22, participant 1 got 14, 19, 16, 22. And if you correlate these two set of scores, the correlation should be above 0.8 for there to be considered as having test-retest reliability. Okay. Otherwise, if the scores are all over the place, that would result to a lower correlation coefficient, and that lower correlation coefficient would be indicative of the lack of reliability of the instrument. Now, if this is established, this is referred to as the coefficient of stability, and it indicates the degree of stability or consistency of the examinee scores over time. However, as a word of caution, you cannot always use test-retest reliability, especially for constructs that are meant to be unstable, such as mood. So you cannot use test-retest reliability for an instrument that is intended to measure mood, because we know that mood is fluctuating. 1 minute you're happy, the next minute you're sad. That happens. So we cannot expect to capture consistency across time for constructs that are expected to be unstable. The next technique in establishing reliability is called the alternate or equivalent or parallel forms reliability. So in here, two equivalent forms of the test are administered to the same group of examinees, and the two set of scores are correlated. So it's the same test, but there are two versions. There's, for example, Form A and Form B, both of which intend to measure the same thing. And to check if there is equivalence in the forms, then the scores should generate roughly the same score, therefore resulting to a high correlation, which is indicative of coefficient of equivalence. The next two are in reference to internal consistency reliability. So in the first one, it measures consistency over time. The second one, consistency over two forms. This one, it refers to the consistency inside the instrument. So the first strategy is called the split half reliability. The test is split into equal halves so that the examinee has two scores, one score for the first half and then another score for the second half. And then these two scores are correlated with one another. If the items are measuring the same thing, there should be strong correlation between the two halves. And that is what you refer to as split half reliability. And finally, the measure of reliability that is necessary or most commonly used for scale development would be internal consistency reliability through statistical analysis, particularly computing for the Cronbach's alpha coefficient. In essence, the Cronbach's alpha is an overall measure of the correlations among the items. And it's measuring, in essence, what you refer to as inter-item consistency. To further illustrate, if there is a scale that measures aspirations for children's achievement, and these are the items, and the instruction is to rate your degree of agreement for these 4 items, then having a strong aspiration for your children's achievement should consistently make you agree to the following sentences. Because all of these sentences are in a way a sample behavior, a manifestation of one's aspiration for your children's achievement, then if I strongly agree with the statement, my child's achievement determine my own success, then I should consistently rate the other items, because the other items also demonstrate similar manifestations of aspirations for children. It will be weird if I say I strongly disagree with one of the items, such as no sacrifice is too great if it helps my child's success, while also strongly agreeing on the other items. Okay, so that is what you refer to as internal consistency. So the kind of the overall correlation of your ratings for all of the items is represented by that Cronbach's alpha. However, there is a new trend that is happening. It's not exactly new. It's been going on for a long time, and that is reviewers of journals are now requesting that instead of Cronbach's alpha, reviewers require us to report another measure of internal consistency, and that is McDonald's omega. There are some advantages of McDonald's omega over Cronbach's alpha. One of which is that the Cronbach's alpha assumes that each of these items, if there are 4 items, are all equal manifestations or indicators of the latent construct. However, that cannot be guaranteed. I cannot guarantee that an item such as my child's achievements determine my own success is an equal manifestation of aspirations for children's achievement compared to I will do almost anything to ensure my child's success, or no sacrifice is too great if it helps my child achieve success. So it's quite possible that although all of these might be manifesting aspirations for children's achievement, some items are stronger manifestations, are more strongly influenced by the construct compared to the other items. And Cronbach's alpha does not account for that. Cronbach's alpha assumes that they are all equal manifestations of the construct. And so to address that, many reviewers are asking for the reporting of the McDonald's omega over Cronbach's alpha. For most tests in social sciences, reliability coefficients of 0.8 or larger are considered as acceptable. So 0.8 means to say that 80% of the variation in the test score is due to the variation in the true score among the individuals. Now, what if your reliability is below 0.80? Does that mean to say that your scales are rendered useless? Not necessarily. There are some scales that are still used despite having reliability coefficients lower than 0.8. They can still be very useful, but it's important that you report the reliability coefficients so that the readers are aware that although we have findings and then we're making these conclusions, they have to consider that the reliability of the scale is not as ideal as one might want it to be. But again, you can still use these scales for as long as you're transparent in reporting the reliability measures. Next, let's talk about validity. So another important psychometric property is validity. This refers to the instrument's accuracy, measuring what the instrument intended to measure or intends to measure. It is important to take note that validity is context dependent. A scale that is valid in one context might not be valid in another context. A scale that is valid among females might not be as valid when males are the ones who are taking the test. So there is that particular caveat. So a test can be valid for one group but not for another group. Now, there are many forms of validity, so let's go through some of them. The first one is referred to as content validity. So there's content validity when the test adequately samples the content of behavior domain that it is designed to measure. If the test items are not a good sample, results of the test will be misleading. Clearly defining the content or behavior domain to be sampled and then writing or selecting items that represent that domain is very, very important in establishing content validity. On part 3, I will talk about how to generate these items. What are your options? One of your options is to develop the items based on the theoretical definition of the construct. Another option is to develop the items from the ground up, meaning to say you conduct a simple qualitative study, and then based on the qualitative study, that informs how you generate the items. So we'll talk about that on part 3. But for the meantime, let's just go through what validity is. So assuming that you already have those set of items, the development or the generation of those items must be guided by our clear understanding that we want to measure this particular construct or this particular variable, this particular domain, and that the items that I have selected and generated is a good representative sample of behaviors that might be manifesting the construct. The establishment of content validity relies primarily on the judgment of subject matter experts. So that means to say that hypothetically, if you're developing a scale that has 3 subdimensions, you define each of the dimensions and then you have generated a set of items for each of the dimensions. So our goal now is to find an expert in the field and then we show the items that we have developed and ask for their opinion if they think the items are a good representation of behaviors that manifests the construct or the latent variable. So here is an example of a content validation form. So as you can see, we have here the name of the construct, active procrastination. We also have here the definition of the construct. This is very important so that the authors has a basis to know whether the items that you have created reflect the construct as you define them. And then you have your items here, and then basically you have several columns. So an accept column, a reject column, a revise column, and then a comments column. So if I'm the validator and if I agree with this item wholly, then I would check the accept column or I will mark it. If I reject it, then I will mark as so. If I say you need to revise, then I will mark it and then I will put on my comments about what to revise. So this is a fairly a simple form that you can use when you seek validation from subject matter experts. Now, another word of caution, it says here subject matter experts, but I think another important thing that you have to consider is that whoever will validate your instrument, it would be better if that person also has some knowledge when it comes to scale development. I think that's also a very important skill for any content validator. Now, assuming that you finalized your set of items and that there is content validity according to the experts, then you would expect that the coefficient for internal consistency would be larger and that we expect that the test would correlate highly with other tests that purports to measure the same domain. So if you develop a scale for academic self-efficacy and then that specific measure should strongly correlate to other measures of academic self-efficacy. And that pre and post test evaluations of a program designed to increase familiarity with the domain will indicate appropriate changes. So that's another indication if there is content validity. For example, there is an intervention that is designed to increase academic self-efficacy. You measure academic self-efficacy before the intervention. Since the intervention is intended to increase that trait or increase that construct, then we would expect that after the intervention, when the participants is measured on academic self-efficacy once again, we expect the appropriate changes. Meaning to say, since the intervention is intended to increase academic self-efficacy, then we would expect that the academic self-efficacy of the participants is already higher. The next type of validity is what we refer to as construct validity. Now, construct validity is not a single thing. Now, there are many ways by which construct validity can be established, but all in all, it's referred to as the characteristic of the test or the scale when it is found to measure the trait or construct that is intended to measure. And like what I've said, it's very complex to establish construct validity, and normally it requires a systematic accumulation of evidence over the years. So that means to say that the more we use the test over the course of many years, the more we're able to establish construct validity. Of course, initially there are some things that we can do. A while ago, I said that an instrument can be reliable but not valid, but we cannot say the reverse of that to be true. We cannot say that an instrument is valid but not reliable. The moment that the instrument is unreliable, it has low internal consistency, automatically that becomes an invalid scale. So that is a number one requirement for construct validity, that there is high internal consistency. So that refers to the question, do scores on individual test items correlate with the total test scores? Are all of the test items measuring the same construct? So that is the first criteria to establish construct validity. Construct validity can also be determined through studying group differences. So, for example, we can ask the question, do scores on the test accurately distinguishes people who are known to have different levels of the construct? For example, theoretically and based on previous evidence, there's a strong belief that females score higher on, let's say, for example, venting as a coping mechanism compared to males, and then we develop a scale for venting. One way to assess whether we've actually measured venting is that when we administer the scale that we created to males and females, it should demonstrate that females scored significantly higher than males, because theoretically they should, and because empirically there has been previous evidence suggesting that females tend to vent out as a coping mechanism more than males. Conversely, if the trait that we develop a scale for is supposed to be stronger among males than when we measure them in males and females, then we should expect that males would significantly score higher on that scale compared to females. Yet another way of establishing construct validity is by conducting research to test hypotheses about the construct. Do the test scores change following an experimental manipulation on the direction predicted by the theory underlying the construct? So again, going back to my example of academic self-efficacy, if there is an intervention that should increase academic self-efficacy, then what we should expect is that there will be changes in the level of self-efficacy before and after the intervention. Or if we are comparing two groups, one group that received the self-efficacy enhancement intervention and a control group, then we should expect that the self-efficacy should be higher in the experimental group compared to the control group. Another measure of construct validity is by assessing the test's convergent and discriminant validity. And this answers the question, do the tests have high correlation with measures of the same trait and low correlations or even negative correlations with measures of unrelated traits or opposite traits? So that is what we refer to as convergent and discriminant validity. So for example, if academic self-efficacy theoretically is strongly related with the actual performance, then the scores for the self-efficacy scale that we develop should strongly correlate with the measure of performance. So that is an evidence of convergent validity. And then we can also correlate it with another trait that theoretically is unrelated to self-efficacy. And when we correlate those two measures, we should not find a significant relationship, or we should find a low correlation. Similarly, if there is a construct that theoretically should be negatively associated with self-efficacy, such as, let's say, for example, procrastination, then our results should indicate that academic self-efficacy negatively correlates with procrastination. And finally, construct validity also means we have to test for the factorial or structural validity. Does the test have the expected factorial composition? Is it really unidimensional or multidimensional as theorized? Some constructs are unidimensional, meaning to say you're only measuring one thing, but some are multidimensional. For example, attitude might have cognitive, affective, and behavioral components. So when we conduct structural validity or factorial validity, normally we do this by running exploratory factor analysis or confirmatory factor analysis. And these tests will assess whether or not the construct is actually unidimensional or multidimensional as theorized. So that is what we refer to as factorial or structural validity. Hopefully I can share with you some tutorials on how to run these analyses for establishing factorial and structural validity. And that concludes my short lecture on the characteristics of a good scale, from the design properties to reliability and validity. So I hope that you learned something. For part 3, I'll talk about some of the guidelines in developing items for your scale. So watch out for that. Again, thank you, and I'm inviting you to subscribe to my channel. Thank you very much. See you around.